I would like to start with actually looking into a typical diagram that includes a transmitter and receiver and the roles of antennas. And we're going to look at the antenna mostly from a systems perspective. We're not going to study in this class antennas from an electromagnetic point of view. So you will not see too many electric or magnetic field equations or integral equations. We're just going to look at the antenna as a device, as part of a device in a microwave system. So the role of an antenna is literally to take the wave that has been generated by the transmitter, and this wave is actually trapped inside transmission lines and land components, and essentially launch it into a free space wave. So as the antenna is trying to do that, it will have basically a number of different properties which we will study briefly. For example, it will do this with some type of inefficiency. It will do that with providing some gain. It will have a specific input impedance that has to be matched. And of course, it will take some type of size and volume to do that. That wave, once it's launched in free space, it will propagate some distance. It could be as low as a few meters and as high as a few hundred miles and even thousands of miles. And it will basically reach the receiver antenna. That wave now is doing the opposite role. That antenna, rather, is going to play the opposite role. It will take this wave and it will try to trap it back into some type of a transmission line. And that wave now will basically hit the receiver, and the receiver will decode the information. So that's the point of view we're actually going to take on antennas. Now, as you decide which antenna do I use for each system, I've listed here a few attributes that you have to be definitely at least aware of. For example, some antennas are low, are narrow band, some antennas are broadband. Some antennas have high gain, some antennas have low gain. Some antennas have high efficiency, some are low. So the point is, again, there is not a single solution that works for every single system. Every system is different, and so we need to understand the trade-offs involved here. So this slide actually gives you a few pictures, so you can get some type of I guess an image of how those antennas might look like. I'm not definitely going to describe all of them, but some antennas I would like to point out. This is the classic dipole antenna, which you probably have seen from your undergraduate days, basically two wires or two pieces of metal radiating. This is an antenna you might find out in walkie-talkies. Usually, if you open that, you will find out a helical antenna in there. This is a classic patch antenna, which is utilized a lot in on-chip as a non-chip antenna. This is the conical antenna, which is a very broadband, very high-quality antenna. And basically, the discussion goes on and off. The main thing I would like you to point out is essentially look at how different the structures physically look like, depending on the requirements we're actually trying to hit.